Hello there, and welcome to Big Data 2.0 IoT as your new operational data source. For a few years now, Big Data and IoT are almost mainstream topics. If we look at the actual deployments, we often see that IoT data stays in its silo, mainly benefiting the service or part of the organization that deployed it. At some point, a CEO will say, hey, I want all that IoT data right within my sales dashboard or my marketing dashboard. If you're a data engineer or an IoT engineer, you may already have heard this. At this point, well, probably it's your call to make it happen. During this session, we will see why it's important to integrate IoT-generated data into your data landscape and get an overview of the strategy and benefits of doing it. My name is Christopher Manner, and I'm a senior cloud advocate at Microsoft, leading our advocacy effort for IoT in EMEA. We will start by quickly introducing the challenges of big data and the kind of data IoT systems produce. Then, we'll talk about the challenges of ingesting and storing IoT data and why it can fit your existing data estate. Then, we'll see why using IoT as an operational data source for your analytical system can unlock insights and actions across your organization. To achieve this goal, we will probably need to work as a team with data and IoT engineers. This session is mainly targeting these two profiles. Let's start with a primer on big data analytics and data management. Usually speaking, big data refers to a system that produces so much diverse quantity of data that traditional BI systems cannot analyze it. We define big data systems with three adjectives called the three V's. First, volume. It's simply the amount of stored data to be analyzed. Then, variety. It's the changing and unstructured nature of the data to be analyzed. As opposed to relational data, where all the data is well organized in a table format, big data systems can analyze semi-structured data like JSON document, or even unstructured data like images and video files. And at least, velocity, which is the frequency to which your system will generate data. In the IoT space, it can be as slow as a metric per hour, up to several data points per second. These three adjectives may seem a bit abstract, so let's talk about why it's probably the biggest big data project in the universe, the Square Kilometre Array Radio Telescope. It's an ongoing international project of radio telescopes based in South Africa and Australia. This project is also probably going to be the paramount of big data projects. This mesh of radio telescopes will provide scientists with 50 terabytes of data to analyze per day. This data will be in form of images and signals with a lot of metadata associated with it. However, there is a lot of more behind it. The actual sensor data generated by the telescope is expected to be 7,000 terabytes per second. All in, they should store something like 600 petabytes of data per year. Okay, you will probably have to deal with much less data than the scientists. But it's a great example of the 3V, volume, variety, and velocity, in a more concrete example. Now, let's have a look at the variety of data IoT system can generate. First, we have telemetry data, mainly using JSON document, even if from time to time we encounter a lot of other data formats, including column-encoded ones. Then, we have all the metadata associated with the data itself, like the device or IoT or system. The values may be changed slowly over time, and this metadata can be precious sources of information for your analytics. This metadata can also be enriched in the process with reference data or other sources of data. The diversity of IoT generated data can be immense. image and video streams, but also many other formats. IoT gateways like Azure IoT Hub facilitates file upload from IoT devices, enabling the collection of all kinds of unstructured data. Getting insights from this kind of data reveals some challenges. IoT data lacks structural consistency. For example, within your IoT deployment, you can have 10 different types of devices that measure temperature. All of them can be using different type and structure of data to report this measurement. This makes it extremely difficult to aggregate and compare. To analyze sensor data and asset data accurately, you need the context of where the data come from, the asset relationship to other sensors, and to access historical performance. IoT data also needs to be analyzed and consumed next to other business data to show the true business impact of IoT initiatives. With a complete IoT deployment, you can have a ton of devices that are pumping out a ton of data. To unlock some insights, specifically if you want to apply machine learning, you will need an almost infinite retention. This requires a crazy amount of storage. If we look at the characteristic of IoT data, you will probably see it's well aligned with big data. To achieve this, data and IoT engineers will need to work together and understand each other. The remaining of the session and the online version of it aims at creating a bridge between these two roles. We've seen why IoT and big data share the same challenges about the type of data they handle. Now we'll see why integrating IoT data as your new operational database is facilitated by Azure solutions. First, we need to see from where the IoT data comes from. When designing an IoT solution, you will probably get all your devices connected to a central hub called an IoT gateway. Azure IoT Hub is a managed cloud gateway in Azure. From there, you can have applications, storage, and databases listening to incoming messages from your devices. You can learn more about Azure IoT Hub at aka.ms/iot10/watch. When you're using Azure IoT Hub, then you can route these messages to several destinations. IoT Hubs offer out-of-the-box support for several storage systems, like storage account, data lake, and time series insights. You can also route these messages to custom-made applications through Service Bus, Event Hubs, or any AMQP or Kafka Open Protocols client. You could also leverage processing services like Azure Stream Analytics or Azure Functions, allowing you to process and enrich and store your IoT data pretty much anywhere you want. Now we saw where the IoT data comes from, let's see where you can land it. The first option will be into relational operational databases. In this case, you will not send all your data or you will be overwhelming your database, of course. But you can send aggregated data with specific conditions. If you already have a data warehouse solution, you can also output aggregated data to it and leverage your existing BI capabilities. NoSQL databases like graph or time series databases can be an interesting destination. For example, you could create a graph representing your sensors and rooms and buildings and even facilities. Doing so, you could simply query aggregated data like at the room level or at the building level. And at least, if you have a data lake, you can probably send all the IoT data into it for further analysis. Of course, Azure provides a range of services covering all these type of data source, from the classical Azure SQL or open source databases like MySQL or PostgreSQL, to an hosted Hadoop cluster with HT Insight. Some Azure services are really a great match for IoT data. You can also leverage open source data source hosted on Azure, like the Azure PostgreSQL or the MongoDB driver in CosmoDB, or elsewhere. If you're looking to model the physical world with interactions, I encourage you to check out Azure Digital Twins service. It enables the creation of a knowledge graph based on digital models of entire environment. This slide is a quick recap about the ingestion technology you can use depending on your choice of storage for the IoT data. If you want to see how you can export your IoT data to a data lake or to an existing data warehouse, you can find demo at the address on the screen. So, we saw that there is a solution to put your IoT data where you want, but is there a data store that is really shines with IoT data? Actually, there is two. The first one is Time Series Insight. We've already seen that Time Series Insight can ingest IoT data easily. You can also create time series hierarchies, allowing you to executing that query to get the average temperature of a building I told you earlier about. You can also get this aggregated data out of TSI easily. We'll see this in a few minutes. If you want to see how you can export your IoT data to a data lake or to an existing data warehouse, you can find the demo on the address on screen. As the volume of IoT data is important, you may be thinking that the second preferred destination would be a data lake. However, a lot of organizations today are not yet ready to really tap into these data stores to get insight or for their dashboarding needs. They tend to favor the existing data warehouse infrastructure with data ready to be analyzed and great security features. With Azure Synapse Analytics, we're bringing you the best of both worlds. Synapse can query unstructured data sitting in a data lake while maintaining a classical table structure you will find in any data warehouse. Due to its distributed nature, you can tap into a huge volume of data in seconds. We just saw that integrating IoT data into your data analytics landscape is possible. Now let's see some concrete examples on how to get insight and actions from your IoT data. If we look back at the request made by the CEO at the beginning of his presentation, one of the most straightforward ways to use your IoT data is by augmenting existing dashboard with them. There, you can see a PowerBI report made by the IT department of Contoso City. On top of several traditional data, now you can have at the bottom of the reports new data coming directly from an air quality IoT deployment. Let's dig into how this report is created. Existing data comes from operational databases. The IoT data comes from two distinct data sources. Air quality alerts are stored in an Azure SQL database from a Stream Analytics jobs. This job will only output a new line in the SQL database when one of the sensors value go above a threshold value. Hopefully, our SQL data table will contain only a very few lines. The graph at the bottom right is a bit different. It's a graph of the sensor readings with an interval of 5 minutes. Here, all the processing is done within Time Series Insight. We are just exposing this data within PowerBI. Using data in PowerBI and exploring historical data with Synapse Analytics are demoed in the online version of this talk. You can watch it at aka.ms/iot40/watch. Data engineers are mostly asked to work on historical data. With PowerBI and Azure, they can also now easily work on real-time analytics. By using Stream Analytics, you can process, aggregate, and filter data coming from IoT Hub in real time and outputting this data to several destinations. For example, you can use the streaming data tile or within an PowerBI dashboard to display this data in real time. No code, no background service, you just have to write a SQL query. But why limiting yourself to crunching and displaying data? When you know how to use Stream Analytics, you're a step away from executing your code, or even better, only a workflow. Here, the same Azure Stream Analytics job is also launching the execution of an Azure Logic app, a no-code serverless workflow service within Azure, allowing me to execute action in a wide range of applications, like sending a message in a specific channel in Teams. Sending real-time alerts to Microsoft Teams and creating a real-time dashboard in Power BI are two of the many demos you will see in the online version of this talk. As I said before, the online version of this talk contains a lot of demos that show you how to build what we saw in this introduction. You can watch it at aka.ms/iot40/watch. You can find all the session resources in the IoT Learning Path GitHub at aka.ms/iot40. You can also get access to all these Learning Path sessions at aka.ms/iotlp. If you prefer to learn by doing, I encourage you to check out this collection of Microsoft Learn modules. Microsoft Learn is a free online learning platform where you can complete interactive learning exercise. Let's finish by crediting this open resource that helped me to make this talk. Thanks for listening, and see you online on Microsoft Learn. Bye.